Okay guys, in this video lesson we're going to take a look at solving for average acceleration. So we've done average velocity. So if we want to go into average acceleration, again we need to define the idea of what is acceleration. So an acceleration is a change in velocity. Okay, so as velocity changes through time, that creates an acceleration. We're going to label that in meters per second squared, or meters per second squared, like this. Again, we do need direction on this because it is another vector quantity, so we're going to be working with positive or negatives, or give us our lefts, rights, east, west, that kind of stuff. Okay. Here's our equation for it. So average acceleration, again, the line above the A just stands for average. It's our change in velocity, of course, through our change in time. Okay, so as velocity changes over time, that's going to be an acceleration, which means we're going to take our final velocity minus our initial velocity divided by time final minus initial time. Typically, time is just set. We just say a duration. So a lot of times we won't need to do this part of it, but it's there just in case we do. Again, our units here, since velocity is meters per second, and we're dividing by time, it ends up being meters divided by seconds, or meters per second squared. Okay? So here's our problem to practice that out. A bus driver steps on the brakes to stop a bus, which is initially traveling at 9 meters per second. It slows to a stop with an average acceleration of negative 2.2 meters per second squared. How long does it take the bus to stop? Okay? So again, if we remember, we want to make sure that we're tracking different things. So we have our displacement, we have our velocity final, our velocity initial, we have our acceleration, and we have our change in time. These are all the variables that we're worried about as we do these problems. So in this case, we're looking for an average acceleration on this. We don't know displacement, so that's not part of this. We're given the initial velocity of 9 meters per second, and we are given an acceleration of a negative 2.20 meters per second squared. Okay. We want to know when it stops the bus, so a stopping means your final velocity would be 0 meters per second. Okay, and we're asking for what is time. All right, so we're setting up our problem. We know what we have, we know what we're looking for. Now we go into our equation. So we know that the average acceleration is going to be our velocity, our change in velocity over our change in time. Well, we know this, and these two things can give us this. So we want to rearrange it to solve for time. So our change in time now can be our change in velocity, which is going to be velocity final minus velocity initial, divided by our average acceleration. So in this problem, we actually know the average acceleration. Now we just need to plug it in. So our change in time is going to be final velocity is 0 minus 9 meters per second divided by a negative 2.20 meters per second squared. Well, we have meters per second divided by meters per second squared. So the label then ends up canceling out the meters, canceling out one of the seconds, and we have a per second in here, which is reciprocal, means it's seconds. So our change in time then is going to be basically a negative 9.00 divided by a negative 2.20. Okay, and our label is going to end up being seconds here as we do this. So take negative 9 divided by negative 2.20. That gives us our answer. All right. So let's take a look at the actual answer then. So here's our acceleration. If we take our negative 9 divided by negative 2.20, we get 4.09 seconds. We're looking at 3 significant figures because there's 3 here, there's 3 here, so answer should have 3 in it. We have a negative divided by negative, so it ends up being positive. Time always has to be positive. If you ever solve for time and you don't get a positive answer, somewhere along the lines in your math you made a mistake on a negative sign. It might be as simple as just ignoring the negative sign, but it also could be a problem with the math you did, and you might be getting a wrong answer also in terms of this, because you may have flipped these, or you may have done something wrong in the actual work. So I would go back and double check it if that's the case. Now, if we're looking at this graphically, we take a look and we see that the slope is known in this problem and the y-intercept is known. Okay? So what we're looking for is, in this scenario, because we know that we are going to go from a velocity of 9 down to a velocity of 0, we don't really know where it crosses the time axis. Okay? We do know the slope though, because the slope of a velocity versus time graph is the acceleration. So we know this is a negative 2.20 slope in here. Okay, we know the slope. Okay, we want to know what happens when y crosses at 0. Okay, so you could set up your normal line equation, set y equal to 0. Remember, in this case, our x and y equals mx plus b would be your change in time, because that's our x-axis, and your b is going to be your initial velocity because we start here at 9. Okay, rearrange it, solving for time, and notice you get the exact same math as you did before. So again, we can use the formula, but the formula actually comes from the fact how it works out graphically. Okay, so either approach is fine. If you want to graph it and then solve using a line equation, that's fine. If you just want to use a formula, that's fine also. Okay. Now, when we take a look at this idea of motion, okay, we've talked about accelerations, we've talked about velocities. So we want to put some sign convention together for you guys, so you now have kind of a chart that helps you understand what is happening to our motion. All right. So the biggest thing is what is going on with velocity versus acceleration in terms of when do we have the same sign and when do we have the opposite sign. All right. So we'll walk through the chart here kind of quickly. When we have a positive velocity and a positive acceleration, we're speeding up. So our velocity should be increasing. We should be getting faster. If you have a negative velocity, remember that doesn't mean small, it just means opposite direction, and the acceleration is the same direction. So if you have a negative velocity and a negative acceleration, both of these are in the same direction, so you're still going to be speeding up. That one's tough for some people. Okay, it's easy to think positive and positive speeding up, but for some reason, because they're negatives, people don't like the fact it's speeding up. But don't think of negative as being less. Think of it as being the other way. So this is to the right. This is just to the left. That's all it means. Now, when the signs are opposite of each other, you're always going to slow something down. So if you have a positive velocity but a negative acceleration, you're going to slow down. Okay. Our last practice problem just had that. We had a positive velocity to start at 9 meters per second, and we had a negative acceleration of negative 2.20. So we were slowing down to a stop. Or if you happen to be going in a negative velocity and you apply a positive acceleration, again, because it's opposite direction, you're going to slow down. Okay. Now, some other scenarios that are helpful for us. If you have a velocity that's either positive or negative and there's no acceleration, you're going to be moving at a constant speed. If you have no velocity and you have an acceleration, okay, this doesn't mean you're at rest. This means you're changing direction. There's an instantaneous point in time where velocity becomes 0 just for this instant point in time. It's not even a second. It's not even a microsecond. It's just this instant in time where there's no velocity. If you are still accelerating through that point, you're changing directions. So the way to visualize this is throw a baseball up in the air. At the very, very peak of its flight, the point at which it stops moving, that's 0. The acceleration of gravity pulling the ball downward is still there. So you threw it up, it's flying upwards, it's going to slow down, slow down, slow down. At some point it stops. It's still accelerating because gravity is still pulling on it. So it's just going to change direction and it's going to move downward back towards your hand. Okay? And of course, if we have no velocity and no acceleration, then we're at rest. Then we're at 0 at that point. Okay? All right, guys, that's going to end this video lesson here. And here we talked about solving for average acceleration, and we also talked about sign convention. Thank you.